Hello, people. Welcome back once again. My name is Richard. It has never changed. Today, we're going to do compounds and stoichiometry, chapter 4 of the MCAT chemistry review. About 7% of all questions that you're going to have on general chemistry will come from this chapter. Compounds and stoichiometry, the name might sound big, but it's pretty simple. Compounds, which means chemical combination of molecules, and stoichiometry, in what quantities are these molecules and atoms being combined in. So that is the basic concept of compounds and stoichiometry. Now, I have some keywords over here that is going to guide us through our exploration of this chapter, because I don't want to veer off too much. So first of all, when we talk about molecules, so molecules are the chemical combination of two or more atoms. Held together by a covalent bond. You see how chronologically we're building this structure? We discussed covalent bonds in our previous chapter, and here it appears over here. Molecules are specific to covalent bonds. Ionic compounds do not form molecules, because as long as there are more of the elements forming that such ionic compound, the compound is going to grow bigger and bigger. So if you pick a crystal of sodium chloride, the amount of sodium in it and amount of chlorine in it would vary as if you pick a different compound of sodium chloride. The reason being that the positive and the negatives of a sodium compound crystals attracts each other. So the more that there is a sodium and the more that there is a chlorine in the vicinity, the compound is going to grow bigger and bigger, forming a crystal lattice. So you cannot specifically determine how many molecules or how many atoms of sodium and how many atoms of chlorine makes up sodium chloride. So they form a crystal lattice. In so doing, we only represent them by their empirical formula. The empirical formula means the lowest whole number ratio that we could distinguish between the sodium and then the chlorine atoms. On the other hand, when you pick covalent bonds, that forms molecule, because molecules are specific to how many of the compound or how many of the atoms are in each specific molecule. If you pick water, for instance, it doesn't matter how big of a water that you do have. If you fetch water from the sea, you fetch water from the pond, a molecule of water is always going to contain 2 atoms of hydrogen and 1 atom of oxygen. It will not change. It does not matter where you get it from. So that thing it forms is called a molecule. So I guess you now understand why I wrote atom here in blue and then covalent bond here in blue, right? So after we've gotten our molecule down, let's move on to moles, right? So when we talk about moles, mole is the amount of substance. And this substance could be anything. It could be people, it could be cars, it could be horses, it could be shoes, it could be atoms, it could be molecules, it could be ions, it could be isotopes, it could be anything. It's amount of the substance. It's a mole, right? A mole is the amount of substance. And this substance can be anything. Right? Anything that is equal to 12 grams of carbon 12 isotope. So we say a mole is the amount of substance that is equal to 12 grams of carbon 12 isotopes. And a 12 gram of carbon 12 isotope is has the Avogadro's number. So the Avogadro's number, which is equal to 6.626 times 10 raised to the power 23 particles per mole, right? So particles per mole. Let's really understand mole here before we move forward to anything forward, right? Back in the day, scientists were trying to find a constant unit of measurement to compare like the amount of atoms that would make up a molecule or a compound. Like if you could count the specific atoms, right? They tried and tried, but they wasn't finding anything that can be like the backbone to compare anything as the number of atoms or particles to. They try oxygen 16 isotope, but then oxygen 16 isotope, they try oxygen 16 isotope, right? Oxygen 16 isotope wasn't in abundance, cannot find it anywhere in like it's not easy to come across. So upon agreement, the scientists decided to use carbon 12. The reason why they decided to use carbon 12 is that one, it is not radioactive, so which means the particles are not going to vaporize as you are comparing them. Two, it is abundant. You can find it anywhere in nature that you look, you could come across a carbon 12 isotope. And then third, it is specific. See, it is carbon 12, so which means it's going to have what? 6 protons, 6 neutrons. It is specific. The ratio is specific, right? There is no veering towards off. Oxygen 16 probably has the same thing, but the reason why they didn't use oxygen 16 is that it might be radioactive, it might vaporize. You cannot find it in nature that much, although the ratio between the protons and then the neutrons might be equal. The other two things were not the same. So that is why they did use carbon 12 isotope. Now, Avogadro made this experimental figure. This is an experimental figure. He figured out that 12 grams of this carbon 12 isotopes contain this amount of particles. 6.626 times 10 raised to the power 23 particles per mole. Sorry, this is 6.6, not 26, 6.602. 6.602 times 10 raised to the power 6.02 times 10 raised to the power 23 of the Avogadro's number. So this is a mole. So a mole is the amount of substance, that is anything, that is equal to 12 grams of carbon 12 isotope. And the 12 grams of carbon 12 isotope contains this amount of particles, 6.02 times 10 to the power 23 particles. So after that, let's move on to molecular weight. Molecular weight. So when we talk about molecular weight, it is pretty synonymous to atomic weight. Molecular weight is the weighted average of all the atoms that makes up a molecule. That is basically it. So it is the weighted average. It is the weighted average of all the atoms that makes up a molecule or compound because ionic compounds also have molecular weight. So it is the weighted average of all the elements, of all the atoms or the elements that makes up a molecule. So if you look at the periodic table, the atomic weight, that is on top of each atom in on the periodic table. If you sum up those things in a specific molecule, it will give you the molecular weight of such substances. So now we found these three and have defined them into an understandable threshold. For example, the molecular weight, let's do like an example here, right? What is the molecular weight of SOCl2? Right? Thiochloride. I believe that is what it is called. So to find the molecular weight of this substance, you should know the atomic weight of sulfur. You should know the atomic weight of oxygen. You should know the atomic weight of chlorine, and then you multiply it by 2. So if we look on the periodic table, the atomic weight for sulfur is 32.1 atomic mass units. For oxygen is 16, right? 16.0 atomic mass units. And for chlorine is 35.5. If I'm not mistaken, it's 35.5 atomic mass units. But it is all times what? 2. So if we sum all of this together, we're gonna do 32, 16, 35, 35.1, 0.0, 0.5, 0.5. If we sum this, is gonna be 11, 1, remainder 1. 5, 5, this is 10, this is 16, this is 17, 18, 19. So it's gonna be 9, remainder 1, 3, 6, 9, 10, 11. So the molecular weight of this compound is going to be 119.1 atomic mass unit. I didn't use a calculator, and I went through it step by step because on the MCAT there is no calculator. You better take your time and do simple math like this, or you could look at it and then arrange it. So that will give you the molecular mass, the molecular weight of a substance. Also, let's veer off a little bit and go into the moles, right? Let's find the moles. If we could get a question that says how many moles are in 9.5 grams of magnesium chloride? So how many moles are in 9.5 grams of magnesium chloride? 9.5 grams of magnesium chloride, right? How many moles? The formula for finding moles, right? N, which is moles. Moles is N, right? Of magnesium chloride is equals to the mass of the substance. So mass, which is measured in grams, right? Divided by the molar mass, which is also divided by grams per mole, right? So at the end, the gram will cancel gram, and since this is per mole, it will flip because it's going to be 1 divided by 1 over mole, right? So if you do the math, it's going to be over here like 1 divided by 1 over mole. And when you flip the division sign, it's going to be 1 times mole over 1, and then it will be mole. These are also some of the basic mathematic principles that we should know. So we have 9.5 grams of magnesium chloride. We put our 9.5 over here, grams, divided by what is the molar mass of magnesium chloride? We find it exactly as we did find the other one. So we're finding the molar mass of magnesium chloride represented by big M, or big MM of magnesium chloride. We're going to have magnesium has atomic number, it has atomic weight of 24.3. So 24.3 plus 2 into bracket chlorine, which is 35.5. So 24.3 plus, even if it was 35, it would have been 70. So it's going to be 71. So 71 grams. This is also grams. 24 plus 71 will give us, this will give us 5. This will give us 9. It's going to give us 95, right? So we have here 95 grams per mole, right? So we divide here by 95 grams per mole. The grams will cancel gram, and then so the N, which is the mole of magnesium chloride, will give us 95 divided by 9.5 is 0.1 mole. So these are such examples that you are going to face, and by so doing, I have just worked one examples of each. Once this chapter is done, I'm going to be working towards like work examples of the various chapters that we have covered. I am targeting about 15 to 20 work examples per chapter, and I'll be making 1-minute videos on them, so it doesn't have to be like a long 1-hour video that it would take time to watch. So we've gotten molecular moles and molecular weights down, right? Now let's move on to the gram equivalent weight versus equivalence, right? So these three things, the gram equivalent weight, equivalence, and equivalent weight, right? What are they specifically? First of all, let's take equivalence. Let's go to equivalence or equivalent. When we talk about equivalent, it's basically, listen to the English. Equivalence, like how much is equal. My left hand is equivalent to my right hand. How many of my left hands will give me one of my right hand? Equivalent. Equivalent. So when we talk about equivalent, what we mean is that how many moles, right? How many moles, and it's always moles, right, of a substance will produce 1 mole of a substance or of a preferred or of a substance that we are interested in, of an interested substance. Let me just underline these things. So that is just equivalent. So if you look at it, equivalent is a mole to mole ratio of how many substance would produce equivalent of a substance that I am interested in, right? So a substance that I am interested in could be hydrogen ions, H+, could be hydrozonium ions, OH, could be H3O, could be electrons, right? Could be protons, right? So it is the substance that I am interested in. How many moles of that substance, of a substance that I have in hand, will produce a substance that I am interested in? For example, right, magnesium would produce 2 moles of electrons, right? So if I want 1 mole of electron, how many moles of magnesium will produce 1 mole of electron? Half a mole of magnesium will produce 1 mole of electron. So then I say the equivalence of 1 electron to magnesium is what? Half, right? Also, sodium will produce 1 electron, right? So how many moles of sodium will produce 1 electron? Is 1 mole. So the equivalence of sodium to electron is 1. Same thing, if I have this acid, H2SO4, sulfuric acid, right? 1 mole of sulfuric acid has the power to produce 2 moles of hydrogen ion or proton, right? So if it has 2 moles, and if I want to just get 1 mole of hydrogen, and then I have 1 mole of H2SO4, what will be the equivalent? Half. Then I would just need half mole of H2SO4 to give me 1, because the mole is what? 2. Right? Same thing. If I have hydrogen chloride acid, how many moles of hydrogen ions can this produce? Same one, right? That means if it dissociates completely in water, it will just produce 1 mole of hydrogen gas. Right, so this is called the equivalent. This is a mole to mole ratio of the substance that we have to the substance that we are interested in. Is that simple enough? So once we have an equivalence down, let's move on to equivalent weight. Equivalent weight. It's gram equivalent weight. Sorry about that. So when we talk about gram equivalent weight, as we said, the equivalent weight is the mole to mole ratio, right? The moment we put gram here, we are limiting the measurement to the mass, right? So this equivalent has no bound. It is just mole to mole ratio, right? If we put the gram here, we are limiting the measurements to the grams. So it is how many grams, it's how many grams of a substance that I have will produce 1 mole of a substance that I am interested in, right? So as I said, the equivalent weight, the gram equivalent weight, over here we have bound the measurement to the measurements of grams. So the gram equivalent weight will be how many grams of a substance that I have of a substance will produce one equivalent of a substance I am interested in. Now, let's pay attention over here. We said the gram equivalent weight is how many grams of a substance will produce one equivalent of a substance that I'm interested in. And a substance that I'm interested in could be hydrogen ions, OH minus, H3O, electrons, protons. It goes on and on, right? And we said that equivalence is how many moles of a substance will produce 1 mole of a substance that I'm also interested in. So by so doing, you can just say that equivalence, the gram equivalent weight, right? How many grams of a substance? So gram equivalent weight is equals to how many grams of a substance. So grams of a substance of a substance that I have, right? Of a substance that I have divided, right? Divided by the equivalence, which equivalence could be replaced by n, which n is the equivalence, right? So that will be the gram equivalent weight. And usually, since I said how many grams of a substance will produce this gram of a substance over here, right? It is usually the molar mass of the substance. Because if I have just 1 mole of a substance, its mass or its grams is just one, it's just if I have 1 mole, its mass is just the basic molecular weight of the substance. So I could thereby change this whole definition for it to be the molar mass, right? The molar mass divided by n, where n is the equivalence, right? Or where n is the particle that I am interested in. In other words, the equivalence. So for instance, for us to get this into a conceptual understanding, once again, let me go over it. Equivalence is how many moles of a substance will produce 1 mole of a substance that I'm interested in. And those could be hydrogen ions, hydrozonium ions, H3O, electrons, protons. The gram equivalent weight, if I add a gram to it, I bound the measurements into grams. Is how many grams of the substance that I have right now will produce 1 equivalent of a substance that I am interested in. And then we came out with a formula that then the gram equivalent weight will be the molar mass. Because usually if I have just 1 mole of a substance, its mass is its average or is its molecular weight. So it will be the molar mass. In other form, molecular weight of the substance divided by the n, where n is the number of the particles that I am interested in, which could be hydrogen, oxygen, H3O, electrons, so on, and then so forth. Let me see if I could find work examples for us to go through. Okay, so for instance, let's say we are to find the gram equivalent weight of sulfuric acid, right? Find the gram equivalent weight of sulfuric acid, H2SO4, right? Now, if we say find the gram equivalent weight of sulfuric acid, it wasn't given the grams of the sulfuric acid, so we have to assume that we have 1 mole of this sulfuric acid. So the 1 mole of this sulfuric acid will have a molar mass of 1 mole of this will have a mass of its molar mass. That is it. So the molar mass of the sulfuric acid, which is molar mass of H2SO4, would be 1 times 2 for the hydrogen plus sulfur is 32 is 1 times 32 plus 4 times 16 for oxygen. So it's going to be 2 plus 1 times 32 is 32 plus 4 times 16 would give us 16, but even if it's 15 times 4 it will be 60. So 16 by 4 was 424. This is 4, remember 2. 4 1 4 plus 2, which is 6. It's going to be 64. So when you sum them together, you have something like 32, 64, 2. 4, 8, 8 over here, 9. You got 98 grams per mole, right? Divided by, so we have the molar mass already. Now, what is N? Right? N, as I said, is the number of particles that we have. In other words, in its equivalent, right? If you put this N in your head as its equivalent, you will just find it over here that 1 mole of the sulfuric acid will produce 2 equivalents of hydrozonium ions, which is 2 over here. So over here, we would be like the N is equals to 2. So the gram equivalent weight would give us 98 divided by 2, which will be what? If it was 90, it will be 45. 8 divided by 2 is 4. 45 plus 4 is 49. So we have 49 equivalents, right? So the unit is going to be grams per mole of hydrogen plus. We're going to do more work examples when this chapter is completed, so you will get that one ingrained in your brain. So far, how many formulas have you gotten? We've gotten that a mole, the mole of a substance, and is equals to the molar mass divided by, the mole of a substance is equals to the mass of the substance. So mass divided by the molar mass. And we've gotten that the gram equivalent weight is equals to the molar mass again. The molar mass divided by N, where N is a equivalence of the particles that we are interested in. So that will do it for the part 1 of this chapter. All right, let me add normality to the thing, to the first concept. So let me add normality over here. Normality. So when we talk about the concept of normality, we are basically talking about the potency of a compound, which is an acid or base or whatever, the potency of it, of the substance that we are interested in is concentration. So how much of the substance that we are interested in are in a certain concentration of a compound we have in hand. So normality is basically a measure of a concentration in equivalence per liter. So let me wipe this here and put normality over here. So normality is a measure. So it's going to be a measure of concentration in equivalent per liter, right? So if we say one normality of one normality of sulfuric acid, we means that sulfuric acid has 1 mole per liter of hydrogen ion concentration in it. So if you encounter this, one normality H2SO4, right? What we're talking about is that this H2SO4 has 1 mole per liter of H plus ions in it. Now, the concentration of the H2SO4 itself might be the same or might change, but the normality here, if we say one normality is equals to 1 mole per liter of the hydrogen ions. Now, if we want to find the actual normality, the actual concentration of the substance, the formula for normality is given by. So normality is equals to the concentration, which is the molarity, right? The molarity. It's going to be the molarity multiplied by the N. So this is normality.